The ability to control and reverse morphogenesis through external stimuli such as electric fields and gap junction modulation has profound implications for regenerative medicine. Understanding the mechanisms that allow Hydra to regenerate from even dissociated cells could pave the way for novel therapies and treatments aimed at repairing or regenerating damaged human tissues. The interdisciplinary approach combining physics and biology has unveiled new principles governing the regeneration of Hydra. This research not only advances our understanding of Hydra's regenerative capabilities, but also sets the stage for transformative advancements in regenerative medicine. By exploring the complex interplay between physical forces and biological processes, scientists are unlocking the secrets of life, one electric field at a time. The groundbreaking research on Hydra regeneration has not only illuminated the role of electric fields in biological development, but has also raised pertinent questions about the broader implications of electromagnetic field, EMF, exposure from consumer products. A key discovery in this research is the critical role of field modulation in guiding morphogenesis, suggesting that the way fields are modulated could have profound effects on cellular communication and consequently, organismal development and health. The Hydra experiments demonstrate that modulation of electric fields can either facilitate or disrupt normal biological processes, such as regeneration. This modulation, or the variation in amplitude, frequency, and waveform of electric fields, appears to be a vital parameter in how cells interpret and respond to external cues. In the context of Hydra, specific modulation patterns of electric fields were found to control the organism's ability to regenerate, pointing to a sophisticated level of cellular communication that goes beyond mere chemical signaling. The conversation inevitably turns towards the ubiquitous exposure to EMF from wireless technology and consumer electronics. Current safety guidelines, such as those established by the FCC, focus primarily on the thermal effects of EMF exposure, essentially, the heat generated by these fields and its potential to cause tissue damage. However, the insights gained from Hydra regeneration research suggest that the modulation of EMFs could have non-thermal biological effects that are not accounted for in these guidelines. The gap in safety testing. The modulation of wireless signals is a fundamental aspect of modern communication technologies, enabling the transmission of data over various frequencies. However, the biological implications of these modulated fields have not been thoroughly investigated in the context of safety testing. The focus on thermal effects neglects the possibility that certain modulation patterns might disrupt or alter cellular functions in ways that could lead to adverse health outcomes. This oversight highlights a significant gap in our understanding of EMF exposure risks and underscores the need for safety standards that consider the biological effects of field modulation. Visit www.rfsafe.com to learn more.